And here we go. Um, okay, so today we're going to talk about polarization. This one's going to be pretty short, about as short as it was yesterday. Polarization, when Polaroid company started making cameras, and they actually started with camera filters, they discovered that it was possible for them to, well, it was possible for them to filter light in such a way to make all the waves travel in only one direction. Light, the way we have it right now, travels. It's a transverse wave, and it travels. I'm going to try and do this in 3 dimensions here. So this is, it's a little tricky. Let me go to straight edge. And okay, so there's our wave, and it's coming at us, kind of. All right, so it's coming out like that, ish. But it doesn't all just travel straight up and down. If you have light shining at you, it's traveling in the direction of the wave is traveling all over the place. So it could be like that. Okay, it could be out of phase this way. Okay, or it could be up. I'm doing all these different colors. Okay. So in other words, the idea is that it's coming at you. The waves, the orientation of the wave. Okay, it could be coming at you, like this. Okay, so I need you guys watching over here, please. Okay, so we're coming at you like this. It would be coming at you like this. We're at an angle like that. However the wave is trapped when you see it. Polarization is a filter that we are able to put onto the wave that once the wave passes through the filter, let's get my once the wave passes through the filter, all of the waves are now in the same orientation. That's not good. My pen's running out. Okay, so all of the waves have the same orientation. So in other words, they're all vertical, okay, or they're all horizontal, depending on the filter. So you have your filter has a direction, and it causes all of the waves to block out, so that they will only pass through with the component of the wave that's in that direction. Okay, so if we have an up and down filter, all of these waves will pass through, but only the part of it, only the XY part of it that's in that direction. Well, what this allows us to do is create directional light. The wave can travel, either only up and down, or we can do it only side to side. You follow that? All right. So we can use that, and one of the more popular uses of that right now is in 3D movies. When you wear your 3D goggles at the movie, Okay, you have one of your lenses is polarized this way. Oh. There you go. One of your lenses is polarized this way. And the other lens is polarized this way. Okay? Because if you have a filter in this direction, light that is traveling up and down can't go through. And if you have light that's traveling side to side, it can't go through a vertical filter. Okay, only light that's up and down can go through a vertical filter, and only light that's side to side can go through a horizontal filter. So what happens is in a 3D movie, over on your screen, you really have two movies being played. You have two projectors showing your screen. Okay, and one is your left eye, and one is your right eye. Okay. And so the light from one of them is polarized in that direction. Okay, and the one from the other eye is polarized in this direction. So when the light bounces off, comes out of the projector, it bounces off the screen and into your eyes through your, through your lenses. Only the side-to-side light passes through, the side-to-side filter, and only the up and down light passes through the up and down filter. And so now your eyes are getting two different images, which is how our brain works. Our eyes get two different images, and that's how we see things in three dimensions. Our brain calculates the parallax on that. Yeah.
What happens if I've done it a few times when I was younger, like took off my 3D glasses, had a 3D movie, and like it really screws up your eyes.
Yeah, it gets all blurry, right? Because it's because you're seeing, both eyes are seeing both signals at the same time. Okay, and so it's kind of confusing, and you're not sure, and they're slightly off of each other. Okay, so you're getting, if this is the image you want to see, you're getting a second image that's just kind of off to the side of it. Okay, but both eyes are seeing the same image. When you put the filters on, one eye sees one image, the other eye sees the other image, and so that's how they control the two different images getting in your eyes, and that's how you see that's how they imitate the depth perception. Okay, so this is also used for other purposes. If you guys are fishers, if you're anglers, I should say. Okay, if you're out on when light hits a body of water, okay, let's do this. When light comes in, right, it's got these different angles to it, hits the body of water. When it comes off, light is polarized. All the light that bounces off a body of water is polarized. It all bounces off in the same direction. I believe it's vertical. So, if you use polarized sunglasses, that reflected light that's off the surface, okay, goes away. It doesn't get into your eyes. And so that allows you to actually see deeper into the water and see what's beneath the surface of the water better. That's why anglers, fishermen, use polarized lenses. Other thing is, if you look at your iPhones, you guys ever notice that you put your sunglasses on, your iPhone looks funny? You ever tried that? No? Yeah? Okay. And I think it's iPhones in particular. I don't know if it happens with Android. But the screen on an iPhone, the LCD screen, is also polarized. And so, or some of the light is polarized. And so when you look at it, through your sunglasses, the light gets distorted and the colors get distorted because some of the frequencies aren't passing through with the other ones in polarization. So that's the idea behind polarization. The stuff you guys are going to do today, you have the polarization page 3 and 4, and that's it.